Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn more physics, chemistry and mathematics, then you have to subscribe to my channel. Please do subscribe to my channel. So in my previous videos, I was explaining about the polynomial chapter, which is the second chapter of 9th standard mathematics. So in this particular video, I'll be explaining the next concepts which are there after exercise 2.2. That is, I'll be explaining remainder theorem and factor theorem in this particular video and try to solve some examples which are given here. So now what do you mean by remainder theorem? So generally, before going into a polynomial, let me take one number. So for example, I'll take one constant polynomial, that is 5, and let me divide this particular number with 2. So here clearly you can see 5 is dividend and 2 is divisor. So that means here whenever you divide a particular dividend with divisor, you will end up getting quotient and you will also get a particular remainder. So you will get quotient and remainder whenever you divide a particular number with another number. So now here when you divide 5 and 2, here dividend is, so I will take dividend as capital D and I will take divisor as small d. So what is capital D? Here capital D is 5, that is dividend, and divisor is 2. Now what is the quotient here? Whenever you do 5 divided by 2, here you can do the traditional division method. So here 2 into 2 is equal to 4. So 5 minus 4 is equal to 1. So that means here 2 will act as the quotient Q and this 1 is the remainder R. So quotient Q is 2 and remainder R is equal to 1. Always you should remember one thing, that is dividend capital D is equal to divisor multiplied with the quotient plus remainder R. So here you can substitute the values and cross verify. Here what is the dividend? 5. What is the divisor? Divisor is 2. What is the quotient? Quotient is 2. What is the remainder? Remainder is 1. So when you solve this, 2 into 2 is 4 plus 1. So 4 plus 1 is 5. So that means here you are getting 5 is equal to 5. So that means this particular equation holds good. Now this particular equation what you have got, you can apply the same for polynomials also. Here you can consider p of x as a particular polynomial which acts as dividend, and let us take a quotient q of x as the quotient of this particular polynomial, and let us take divisor, a particular factor which is equal to x minus a. So x minus a is a linear factor which acts as the divisor of this particular polynomial p of x, and let's take p of a as the remainder of this particular polynomial. This will give you quotient which is equal to q of x and it will give you a remainder which is equal to p of a. So this is one condition which you can remember. D is equal to, that is dividend is equal to divisor into quotient plus remainder. Similarly in the polynomial case also you can consider this. So d into quotient plus remainder. So here in the place of dividend we have taken p of x and in the place of quotient we have taken q of x, and x minus a is the divisor and p of a is remainder. So you can substitute here. So divisor is x minus a, quotient is q of x plus remainder is p of a. So this equation is very important to understand factor theorem. That means here whenever you do p of x divided by x minus a, so whenever you do p of x divided by x minus a, you will get quotient equal to q of x and remainder equal to p of a. After understanding this particular equation in remainder theorem, we will try to understand how factor theorem works. So now we will try to understand what do you mean by factor theorem. So in factor theorem, whenever a remainder becomes 0, then the divisor is the factor of that particular polynomial. Or whenever the factor of the polynomial is the divisor, then that particular polynomial's remainder is 0. So that means here we had this equation p of x is equal to x minus a into q of x plus p of a. So here whenever p of a is equal to 0, then x minus a becomes the factor of p of x. So then x minus a becomes factor of p of x. This might be confusing you. How can x minus a become factor when p of a is equal to 0? So let me explain that using a particular number. Before going into polynomials, if you try to understand this using numbers, then you can understand similarly for the polynomials as well. Now let me take 4 as the dividend and let me take 2 as the divisor. So what is the value for 4 by 2? So here what the quotient you will be getting. So when you divide 4 with 2, 2's are 4. So here clearly you can see 0 is the remainder, 2 is the quotient. So that means here dividend, that is 4, equal to divisor into quotient. What is divisor? Divisor is 2. What is quotient? That is also 2. Plus what is remainder? Remainder is 0. So here clearly you can see remainder is the 0 and here 2 is the divisor, small d. So you can clearly see 2 is the factor of 4. So here you can see 2 is the factor of 4. So that means whenever you take a particular number and divide the number with the factor, then always you'll get remainder equal to 0. So that's why here if 2 is the factor, then remainder becomes 0, or if remainder is 0, then 2 becomes the factor of this particular number, of this particular dividend. Similarly, here in the place of dividend, we are taking polynomial p of x, which is equal to divisor, that is x minus a, into quotient, that is q of x, plus remainder, that is p of a. So here whenever p of a becomes 0, then x minus a becomes the factor of p of x. So whenever x minus a is whenever p of a is 0, then x minus a becomes factor of p of x. It is similar to this particular equation. So 4 is equal to 2 into 2 plus 0. So that means here remainder is 0. So that means 2 is the factor of this particular 4. Or if 2 is the factor of this 4, then remainder becomes 0. Simple. It is as simple as that. So that's why here whenever you have x minus a as the factor of p of x, so vice versa is also true. So whenever you have x minus a as the factor of a particular polynomial p of x, then remainder becomes 0. That is p of a is equal to 0. So here x minus a means here this particular a what you are considering should be there as p of a. So that p of a is equal to 0 means the a value, if you are subtracting with that variable, that is x minus a, that becomes the factor of p of x. If the x minus a is factor of p of x, then p of a, that means whatever is getting subtracted with this x, so that if you are substituting in the polynomial, then that particular polynomial will be equal to 0. So that means remainder you are getting as 0. So that's it. Similarly, if you try to understand this using these numbers, this factor theorem will become very much easier. Still, if you have not understand, you can watch this multiple times so that you will understand. So in order to understand this particular numbers you have to consider in the place of polynomials and try to understand using numbers. Then with polynomials you can easily understand this. Now we will try to understand example 6 using this particular concept what we have learned now. So now you have to examine whether x plus 2 is the factor of. So now you have to analyze whether x plus 2 is the factor of polynomial x cube plus 3x square plus 5x plus 6. So here x plus 2, whether we have to understand whether this is the factor of this particular polynomial, then p of a should be equal to 0. So what is a in this case? Here x plus 2 can be written as x minus of minus 2, because x minus of minus 2 will be equal to x minus into minus will be plus. So x plus 2, again you are getting this x plus 2. So that means I can write this x plus 2 as x minus of minus 2. So now you are getting x minus a as the divisor, and you have to see whether p of a is equal to 0. So here minus 2 is a. So now you can substitute p of a, that is p of minus 2, in the polynomial. So what is the polynomial given here? The polynomial given here is x cube plus 3x square plus 5x plus 6. Now you can substitute minus 2 here. So it is minus 2 whole cube plus 3 into minus 2 whole square plus 5 into minus 2 plus 6 will be there. So minus 2 whole cube is minus 8, because 3 times you have to multiply minus, that is minus into minus plus, again plus into minus will be minus. So 2 cube is 8. So minus 8 plus, here minus 2 whole square is there. So minus 2 into minus 2, that is minus into minus plus, 2 into 2 is 4. So 3 into 4 is 12. So minus 8 plus 12, 5 into minus 2 is minus 10 plus 6. So here you can see minus 8 minus 10 will be minus 18. 12 plus 6 is plus 18. So minus 18 plus 18 is 0. So that means here x plus 2 is the factor of, so x plus 2 is the factor of x cube plus 3x square plus 5x plus 6. Here they have given one more polynomial, that is 2x plus 4. You have to take this polynomial and you have to say whether x plus 2 is the factor of 2x plus 4 or not. So for this 2x plus 4 polynomial, whether x plus 2 is the factor or not, you have to check. So here also you can take p of minus 2. So here if you substitute minus 2 in this particular x position, it will be 2 into minus 2 plus 4. So 2 into minus 2 is minus 4. So minus 4 plus 4 is equal to 0. X plus 2 is also the factor of, the second polynomial which they have given here, that is 2x plus 4. Now let us try to understand example 7. Here you have to find out the value of k in the polynomial 4x cube plus 3x square minus 4x plus k. And one hint they have given here, that is x minus 1 is the factor of this particular polynomial. So here x minus 1, so this we will consider as p of x. So here x minus 1 is the factor of this particular polynomial p of x. So that means here x minus 1 is there, means this is nothing but x minus a. So in the place of a you have 1. So if x minus 1 is the factor of p of x, in factor theorem we discussed that if p of a is 0, then x minus a will become the factor. If x minus a is the factor of polynomial, then p of a will be 0. So here x minus 1 is the factor of this particular polynomial. So that means p of 1 is equal to 0. So now you substitute p of 1 in this particular polynomial. So according to factor theorem, here p of 1 is equal to 0, because x minus 1 is the factor of this particular polynomial. So that's why p of 1 is equal to 0. So what is the polynomial they have given here? The polynomial which they have given here is 4x cube plus 3x square minus 4x plus k. So now you can substitute 1 in this particular polynomial, that is 4 into 1 cube, because we have to calculate p of 1. So that is anyway equal to 0. So because we have to calculate the value of this particular k. So 4 of 1 cube plus 3 of 1 square minus 4 into 1 plus k. this is equal to 0. So this is P of 1. So this is P of 1 which is equal to 0. So what is 4 into 1 cube? 1 cube is 1. So 4 into 1 is 4 plus 3 into 1 is 3 minus 4 plus k. Here minus 4 and plus 4 gets cancelled with each other, which is equal, this entire equation will be equal to 0. So 3 plus k is equal to 0. So k is equal to, if you bring 3 to the RHS, it will become minus 3. So k is equal to minus 3. So now let us try to factorize polynomials. So now let us try to factorize the polynomials. So we have to factorize polynomials. So to understand how to do factorization of a particular polynomial, we'll take one example. Here straight away let us take example 9. So we'll consider example 9 for this. Here the polynomial which they have given is y square minus 5y plus 6. So here two methods you can use to find out the factors of a particular polynomial. One is directly you can split the middle term and take the common, or you can directly use the factor theorem and try to factorize this particular polynomial. So we'll try to understand how to factorize this polynomial using both the methods. Now first we will use splitting method. So first we will use splitting method. So in splitting method there is one particular trick which you should remember. So here whenever you have this particular value like this, the first value what you have here, that is the coefficient of y square, and the last value, that is the constant which is there in this particular polynomial, that you have to consider. So here coefficient of y square is 1 and the constant which is there in this particular polynomial is 6. So here 1 into 6 is equal to 6. So now you should look for those two numbers where if you add those two numbers it should give you minus 5, and if you multiply those two numbers that should give you this particular 6. So that means here you have minus 5 and here you have 6, that is multiplication of 1 and 6. So that means if you are considering a and b as the two terms, then so a into b should be equal to 6 and a plus b should be equal to minus 5. So if you consider minus 2 and minus 3, then minus 2 plus of minus 3 gives you minus 5, and minus 2 into minus 3 give you plus 6, because minus into minus is plus, so 2 into 3 is 6. Y square minus 5y plus 6 is equal to, so that means here y square minus 2y minus 3y plus 6 you can take. You are getting polynomial as y square minus 2y minus 3y plus 6. Here you can see y and y are common in these two terms, so you can take y as the common factor, and here inside bracket you will have y, because y into y will be y square, minus 2 will be remaining, minus here 3 you can take common, so minus 3 I will be taking common. So when I take minus 3 as common, so y will be remaining. When I take minus 3 from plus 6, then minus 2 will be remaining, because minus 3 into minus 2 will be minus into minus plus, 3 into 2 will be 6, that is plus 6. So that means here we have y into y minus 2 minus 3 into y minus 2. So here in these two terms you can see this particular y minus 2 and this particular y minus 2 is common. So those y minus 2 you can take common, and what is remaining, y and minus 3 is remaining, so that you can take inside bracket, that is y minus 3. So here y minus 2 and y minus 3 are the factors of this particular polynomial. So here y minus 2 is one factor, y minus 3 is another factor. Now we will try to use the factor theorem. So now we will try to use factor theorem to solve this particular example. So now using factor theorem we will try to calculate the factors of this particular given polynomial in example 9. So that is p of y is equal to y square minus 5y plus 6. So this is the polynomial which we have. So here if y minus a is the factor of this particular polynomial, then p of a should be equal to 0. So now we don't know what is a here, so that's why simply you can take this constant which is there in the polynomial and try to take the product between this constant and coefficient of this particular y square. So that is nothing but 1 into 6, which is equal to 6, and try to find factors of this particular 6. So now try to find out factors of 6. So what are the factors of 6? Factors of 6 are 1, 2 and 3. So 1, 2 and 3 are the factors of 6. Here we will try to see which particular factor of 6 will be giving you p of a as 0. So that means here now in the place of p of a is equal to 0, we'll try to take p of 1, that is the first factor. So p of 1 means here we have p of y is equal to y square minus 5y plus 6. This is the polynomial which we have. Now we are calculating p of 1, that is the first factor of 6. So that is p of 1 is equal to p y square is there, so 1 square minus 5 into 1 plus 6. So that means 1 minus 5 plus 6, which is equal to, so that means here y minus 1 is not root of p of y. So here y minus 1 is not the root of this particular polynomial p of y. Now we will try this with this particular p of 2, because 2 is the factor of 6. So that means here 2 square minus in the place of 5y we have 5 into 2 plus 6. So what is 2 square? 2 square is 4 minus 5 into 2 is 10 plus 6. So 6 plus 4 is 10. So 10 minus 10 is 0. So that means here y minus 2 is the factor. So y minus 2 is the factor of p of y. Now we will take one more factor of 6, that is 3. So p of 3 is equal to y square. So that is nothing but 3 square plus minus 5 into y is there. So minus 5 into 3 plus 6. So 3 square is 9 minus 5 into 3 is 5 3s are 15 plus 6. So 9 plus 6 is 15. So 15 minus 15 is 0. So that means here y minus 3 is also factor of this particular polynomial p of y. So that means here we have y minus 2 and y minus 3 as the factors of so here y minus 2 and y minus 3 are the factors of p of y. So here we have p of y. So here p of y is nothing but y square minus 5y plus 6. We are getting y minus 2 and y minus 3. So y minus 2 into y minus 3. You can write this. So y minus 2 and y minus 3 are the two factors of p of y. Because this particular polynomial is quadratic equation, this polynomial will have only two roots present. So this is all there in this particular video. I have solved some 3 examples in this particular video to make you understand about remainder theorem and factor theorem. So using this particular factor theorem, we will try to solve the exercise 2.3 questions. So in my next video, I will be solving the exercise 2.3 questions which is there in this particular chapter. Until then, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.